So now I think we can at least start now. Sorry for the delay. Yeah, as you can see, this is about, I call it solarized Magenta. Maybe it's not completely accurate, but I think most of you that at least maintain or work for or develop for a bit bigger shop have already encountered problems with the MySQL site search. And we also have this problem, so there are different options for it. But first a little bit about me. I'm Nils. I'm the tech lead for our e-commerce. I'm working for a merchant, Polo Motorrad. We are selling motorcycle apparel, wear, protective stuff, tuning kits, and some no whole motorcycles because it's not allowed in Germany if you're not if you don't have mechanics. But it's a German local stuff. So for us, we started with years ago with the thing, we only had the MySQL search. And then somebody said, yeah, there is Fact Finder. And so we used a SaaS solution with Fact Finder in one store view only, because two of our other store views with different languages don't have this high traffic and so on. And it's a pain to configure something like Fact Finder to bring up really good results if you're not able or willing to do real good data maintenance on your products themselves. So the problem with SaaS and a high amount of requests is it pretty easily gets kind of costly, because at least in our case there was the habit of they calculated a base amount and then they added some request-based amount. And this base amount from the highest request store view has to be paid for every store view. In our case, because we use different domains for our store views. So in this case, it got to a point where the store views weren't generating even the base amount of cost. So in this case, we had to do something, so we kept them for MySQL that yielded different other problems. It was, our SaaS solution for us was fully tuned because we didn't want to tune or maintain the data properly. Or we weren't able to, I don't know. It was before my time I joined Polo. And in this case, we had the severe problem that with the SaaS solution, you normally do the search and tune the results afterwards before they get displayed in the shop. And this is a problem if you try to replace it. The search engine itself with most of the SaaS solutions is also some Lucene-based approach, mostly. The real difference is if you tune your results later, then everything of the tuning is proprietary to this kind of SaaS. And so replacing is even higher, has a higher amount of work you have to put into it, because all this tuning and all these alterations have to be done afterwards again. The thing is, problems, we had really severe problems with a complex search, like like I said, we sell technical parts for tuning, and they are only compatible to different types of motorcycles, and so you easily generate a request with 20 to 50 parameters that gets kind of easily out of hand in such a solution to a degree where Fact Finder normally, or most of the SaaS solutions, are quite fast for the response times, like 20, 50, 100 milliseconds. For the full result, we reached points where we hit timeouts after 60, 80 seconds because the search wasn't really computable on their end. No idea why. The biggest problems we had in our setup were with the two MySQL search store views. As most of you know, not only the relevance of the MySQL search is improvable, to be honest, but it's not well known for its super fast speed, because full text search in a bigger database of full text entries takes quite a while. With super slow, I speak about, we had searches running for 80,000 seconds, 120,000 seconds, and they are blocking the complete store view, because then the result, if you wear a Motorrad motorcycle stuff. Most of our clothing is black. So if you search simply for black, you yield 40,000 results. Every single row the catalog search will insert into catalog search result. And yeah, if you do that quite often, the reindexing of this table, yeah, you know, it gets out of hand. If you have some millions of entries and then try to add 50,000, yeah, it takes quite long, and the next search is waiting, and it got really out of hand. And as I said, the relevance of the results is more than improved. You can easily hit the point where you have no idea why some item is returned, because you cannot figure out how this could in some way match your search criteria. So we settled down and looked for some alternatives. Of course, there are, at least for search, there are really good alternatives with Solr, with Elasticsearch. There are swings for the MySQL and itself, and there are different types of SaaS solutions. There entered some new players entered the world recently, I would say, and we decided on, in our case, the real decision was made between Solr and Elasticsearch, because we said, okay, at least nearly everybody in our team had experience with one of another, and we could figure out it's more or less because everything is only extending the scene in this case, or it's an API to the scene. It's more or less personal preference what to use. There's no real game-changing thing. If you are not hitting, let's say, 120 million requests a day for your search, then maybe the scaling features of one or the other, the easier scaling maybe get interesting, but at least not for us. So we never hit the point where we had more than, I think, 1,000 or so search requests a second. So we're way out of this league where we need to scale this whole thing up. So for search, the relevance is really, really good. At least if you configure and maintain your data sets correctly. For us, the real interesting, the part for the decision was I put my hand up for using Elasticsearch because I already implemented it in one or two shops, but then a new colleague entered our company and he said, yeah, I've done a really big shop with, or a really big search thing with Solr. I said, okay, you have a new project. Really fine for me. And the other hand was, we tried to investigate if we could use swings, because I really heard really nice stuff about it, but none of us had any experience with it, and there is no API available. So you do everything on the machine directly, you have no API for requests and so on. That was for us the thing where we said, okay, maybe if we could extend the use, but in our case, the idea was to do multiple requests for something, and in the end, maybe use Solr for more than that search. SaaS, yeah, as I already mentioned, the adaptability between the different solutions is nearly non-existent. You never get out of this circus altogether. You never get your input out that you have invested in time and knowledge and so on, and the adaptability of it. And yeah, one of the things, like I've already mentioned, we follow this full path of optimizing the result, not the input data. That made some of the migration to a real search engine really hard, but it was doable. It took time, but it was doable. Yeah, so we said, okay, Solr, there is an enterprise edition connector. We are an enterprise customer, but only for very old versions, even for a Magenta way, very old versions. In 1.14, it's only supporting 3.6, and that's the last version. 3.6 is from 2012. Proven technology, but maybe not the thing you want to use now. At least because most of the, if you try to install it, it's not even easy to find some within your package manager that is still supporting 3.something. So there had to be alternatives to the included Solr connector. And there are several third-party modules out there for Solr. Our request was they have to work out of the box, at least to some degree. So it should be at least be possible to have it used as a drop-in replacement for the MySQL search. And yeah, we found a module from a good friend of mine. They just said, yeah, we have a beta. It's not publicly available right now, but you could test it. And we said, okay, we just try it. And then we used it. It's from Magenta. They since then, I think a month or two later, they did a public release, and now it's available publicly. And the one thing what was counting for me was I have a direct connection to some of the developers, so it's possibly easier to extend. Because either you can put in feature requests through a direct line, or because it's open source, it's not free but open source, so you are able to extend it on your own. And that was for us the real thing that we needed, because we already knew that we would need some custom extensions for the search itself. And the real pro arguments for using this at the time was the complete configuration was very easy and understandable. You had a per attribute boost in the Solr relevance. That's kind of interesting for us probably for most people that also offer a printed catalog, or where you have the scenarios that somebody is searching for SKUs directly or something like that. That's easily to implement in there. It's only a configuration setting. And like I already mentioned, the communication flow between us and the developers, it's kind of easy for us. They sit, I think, 50, 80 kilometers from our office, so even a personal meetup, it's no problem at all. Yeah, then it's already from the get-go, this module was doing more than just replacing the search engine. But it achieved it by replacing the search engine. So they came to the idea, yeah, the auto-suggest is a feature that's really needed for most people. And if the suggestions are pretty fast and pretty accurate, then it's always good, because normally you can go directly to the product and don't have to render a big search template with search results and maybe filters on it, or then you yield, I think, 20, 30 products everybody has to look through, and the idea is really good, and it's the implementation there, it's kind of interesting because it's bypassing Magenta completely. It's a direct PHP call, and that makes it very, very fast and easily adaptable, because it's only in one file for the auto-suggest. It's really easy. What in our scenario, because we have I would say at least a difficult product structure. We don't have this typical configurable simple, but so we wanted to skip something from the search, or at least skip it from display, from the search results. So there is a feature for skip this as a Solr entry, for when you index your Magenta stuff into the Solr index. For us, that's exactly what we needed to say, no, this should be in the shop, and it should be available like for a direct link from a marketing newsletter or so on, but please not index it in the search. Superb, very good working. And at least somebody who had a bit of integration with something from marketing, you always know that there is the demand for having some products up front or in the first row or on the first page that maybe don't fit the search results to be on the first page. But that's possible because you can boost it on a per product base. Everything we needed in this case. And yeah, for us, we used it, we did some adaptations, and then we thought, okay, Now we have this infrastructure, we've set up the Solr server and already doing this really time-consuming indexation from the stores to Solr. And about time-consuming indexation, I think when we started we needed around about 80 hours to index everything from Magenta to Solr. A bit of optimization later, we are achieving right now 2.5 hours. So it is possible, but not if you use the Magenta way of doing things. Yeah. So we thought, okay, what we can do to improve performance in general. And yeah, we had a bit of brainstorming and said, okay, maybe we can put our Solr installation to a bit better use because it's already there. We already use this module. We already have the service configured. Every data is already indexed and in the Solr instance. So, and then last year I had a talk with Tibishashvili, and he told me about an idea, a project he did together with Fabian Blackschmidt and Vinay Kopp that sounded nearly exactly what I think. Okay, this could be done with our data and our infrastructure, at least in a way that is not so different from them. And so we came to the conclusion, yeah, there is many possibilities to put this data. We put hard work in to get it structured into Solr and maintained on the product maintainers side to better use. And the idea were to get at least the category product relations out of Solr, because for showing up a category page, it's nothing else than searching for all products that are in this category. Easy task, kind of easy achievable. Then we said, okay, when we get this, why not getting not only the IDs for filtering the Magenta collection, but maybe get every data we put into the Solr. Okay, we had to put some more because that was not our first get-go. But then we said, okay, when we put more data, so every bit of data that is needed to be displayed on the product pages, if it's in Solr, we can get it back from Solr, because the response times compared between the Magenta filtering Magenta collection with IDs and the response from Solr is orders of magnitude. Because I think, we had it, our Solr server right now, it's something between 20 and 80 milliseconds. If the complete result set is returned. And I want to see a Magenta collection of about 80,000 or 40,000 products even processed or starting to process in this time frame. So yeah, and then, okay, it's kind of easy, why not use it even a step further on the product detail pages? Because if the data is already in Solr or can be put into Solr quite easily because there's only some fields missing, then displaying the category pages or the product detail pages is nothing more than using the data already available in Solr, like we had it on the category pages, because it's only a search for a product with a special ID. Kind of easy. You could directly, in our case, you could directly request the document ID, done super fast. And the thing that really blew my mind when I talked to Tim was they also had the idea to keep the complete HTML representation of every possible product display in the data storage. That's the thing we are not doing right now, because right now our index is big enough, to be honest, with 3 different languages and around about 80,000 products with their full data set. It grows, at least a bit. And that would be not the next, but the step after the next step, I would say, in our case. Yeah. Like I said, we have everything in there. That was our first get here. So we only got back the category IDs, put them into a fake collection to have a collection available, because many of the features in the templates rely on product collections on a category page, like the complete the toolbar and the filtering and so on and so forth. Right now we've gone the step further and already rewrote the complete template chain of the category page to a single file template that is parsing just a JSON array that we get back. But that's not live, that's just now in the final testing stages. Like in here, that is what we get, the JSON data back from Solr, and we choose this approach in the first way because it was way faster for the template side. The templates take longer, but the implementation cycle is faster if you only get if you only have to adapt one point, the data getter for the fake collection, than to rewrite the whole templating stuff. And there are things that are not so easily rewritable, like the pricing stuff and so on. I think most of you have looked into some templates of that. Yeah. And yeah, for the product view data, that's that's our hot topic right now. We're right now replacing the complete template and the data getter in one go, not like we did on the category pages, because for us, there's one good thing. Right now we're closing the summer and we are nearing autumn and winter is no motorcycle weather, so season's off. We have time for such a big experiments. But it's the same thing. We first tried to mock up the product model with the data we get back from Solr. It's already working, but that's not so super efficient, because during the mock process or the mocking process of the product model with our external data, there is a huge Magenta internal time consummation about get EAV structures, get attribute stuff and so on. Like we have some attributes with at least many entries. We're talking about, I think, 16,000 colors or so. It's time consuming. This is why we just started to use the time, this is big time, only once during indexation to the Solr, and not on every request. And yeah, that's still something that in our case it could be improved. Right now we're closing the stage for the rebuild of the template. For the category pages, hopefully we get it this month together, and then afterwards we're using it for, we will try to get it on the product view pages. The idea is maybe this can even be put one step further by using it in the front end, on the user side, to parse it with a big JS template or so to put out the complete stuff to reduce server loads. But we will see how the current setup with generating from a static template with only array parsing already affects this. But actually, at least in PHP 7, parsing a big array into an HTML is nearly a no-brainer. There's no time consummation in there anymore. So I think at least in the first iteration we will skip we will not do the front-end rendering, because then you have no hands-on performance and so on. And in the case if you're delivering if you deliver the correct and complete HTML, you still have the possibilities of using some file cache and varnish and so on, if you need it. Yeah. The real benefits for using the HTML in Solr, like I said earlier, is probably it's the most performant solution for the front end, because then you could easily using something like a big ESI template that is getting every block different from the varnish, if you only deliver those blocks in there. And that should be easily scalable, because yeah, Solr installations are scalable easily, and if you really reduce the overhead for the complete content generation in the front end and so on. But on the other hand, the indexation times will skyrocket, because you have to do everything where you possibly see this product. You have to render it in advance for every solution, for every resolution. You have maybe problems if you tune it up too hard with responsiveness and so on, but I think there could be workarounds. But that's a scale where we are not by a far away. It's for us, because right now there are still some of the steps that we have to do up front. Like I said, the problems are in there. I think the index will really be great from the storage amount you need. Everything is kept in RAM. I think right now we're talking about in our setup about 20 gigabytes. And if you multiply it by, I don't know what, to have everything stored in HTML, I think we easily reach 150 or so. And then you hit a thing where you have to scale because of the pure memory consumption in the machine. Right now we can skip it, hopefully for at least some time in the future. And the thing is, if you change templates, you have to rebuild your complete index, and in this case, this will take some time. Right now we say the trade-off is not good enough for us to implement this solution. It could be something that we are willing to do in the future, but not right now. Yeah, that is all. Everything of this is done for Magenta 1 shop. Because, yeah, we weren't eager enough to migrate to Magenta 2 yet, but at least IntelliGenNet started, or at least had started the migration of the Solr connector. I don't know, I know they stopped it in between because of huge API changes from 2.0 to 2.1, but they said, yeah, we will integrate it for Magenta 2. The same workflow can be easily done or copied to Magenta 2. If you put everything of your data into the Solr, then it's easy to do the exact same steps for Magenta 2 like we did it for Magenta 1, because the real, the time-consuming part about it is getting the idea what you have to have in your Solr and get your indexation right. And that maybe is a bit of a challenge for Magenta 2, but as the data storage hasn't changed so much between 1 and 2, it should be easily adaptable, I think. Hopefully I have some answers for your questions, if you have some. I think what is our time frame? I'm timeless today. So, Ivan?
Yeah, I have one small question, like caching over optimizing the queries. So in my opinion, maybe it makes sense to take a look at a different area, like to optimize queries where it's slow on the Magenta side instead of putting everything in cache in Solr.
Okay. I think that it could depend on how complex the stuff is you have to cache. In our case, you're right, it's more or less a bit of a trade-off, because if you have, I think in the case where you have a huge amount of requests, then it's easier to use an approach where it's where it's fast to get your response either from, in this case, Solr, or from a cache upfront. I think in some cases, like I said, Varnish or so, where the static stuff is delivered directly, is the best option, of course, because even the different Solr queries and so on take time, especially on pages with where you have big fragments for layered navigation and so on, because therefore you have to have multiple queries to get it right. And I think if these scenarios get too complex, then it will be hard to optimize it only on the Solr backend, but on then it has to be really hard cached in some specialized for this caching methodology.
Then you might be interested in looking into microservices as a way to build PHP applications that actually keeps in memory the results for both categories.
Maybe, yeah. We already thought about using everything in the. We gave it a try not to use something like Vanish, but local storage. For at least for the JSON stuff we get, because putting everything in local storage, you blow your local storage away. But with only the JSON data, it was possible. I think we have to look into it.
Did you try to use your solution with a huge working environment? Because Solr behaves very strange when there is a lot of stored data in Solr.
We don't encounter this problem.
Yeah, I've been working with a project that has 12 giga of stored data, and it used to just screw up the index, and it's a very risky way to insert HTML or just over data to Solr. It's better to use faces inside Solr to just improve data kept in Solr instead of keeping all the raw data.
Yes, I answer for you.
Yeah.
To make it simple,
Because we also
it's just too much data inside.
What is too much?
No, it's not a problem. Talk to your host, sir.
I would say so too, yeah. Like I said, you said about gigs, I would say right now we use it with us, like I said, indexes of each with, I think the big one is around about 10 gigabytes without HTML. And we never had index issues, beside when we screwed up ourselves. So indexation, breaking the indexation process and so on can yield interesting results, because the searcher, if you don't commit it correctly, then the search indexes get a bit off, and then you can have problems, yeah, but we not encountered it in the last half year or so, where we started implementing the whole setup. And so maybe there is this problem if you have, like I said, super huge data sets. Right now, I cannot imagine, to be honest, for me it's hard to imagine somebody, at least that is using Magento with this kind of approach, that has a big enough data set to screw up Solr. To be honest, I cannot imagine. Maybe there is, but I simply cannot imagine, because I know there are companies using Solr instances with terabytes of data in it, and I've never heard of such problems. Never heard. Just simply, maybe they just passed by, but I never heard of them. So I have no idea what this could be in this case.
Okay, so which instance of Solr you are using? Cloud one or just standalone?
Right now we are using standalone. No, we are using not anymore. We switched to a master and I think 2 slaves, but the 2 slaves are just for availability reasons. We never used them, and we just thought about, for a bit easier maintenance of those, to switch to a Zookeeper managed scenario, where your Zookeeper is managing your Solr cloud. It's possible with Solr 6. And in this case, for us, it's only for availability if some of the servers break. Luckily, we didn't encounter this. So we had no problems with internal data corruption in Solr.
What about maybe personalized content per customer? For example, using price per customer extensions and storage data.
This will increase your Solr index, because you have to save all this data to the Solr index. Yeah, of course, you have to adapt the extension, or at least the data. No, the indexation process that is reading your data, because if it's a third-party module with its own data storage, most of those do it in a different table or so. Yeah, of course, you have to put your data into the Solr, and then it's no problem to get it out. So I think we are.
Sorry, one more. Or, do you have any experience with multi storage and multi stores, like in other languages? Or?
Yeah, we use it in 3 different languages. We use German, French, and English. And right now we adapted a Polish one. So.
And multi inventory?
No, we don't use multi inventory because it's a pain on the thing you're sitting on in Magenta 1. It is possible, I know, there's one extension that's not really working, at least as I know, and so we have the request, we try to build it our own. It is working for us, but I would not recommend using those. We're using it with 120 different inventories. It's the indexation times are, nothing to laugh about. So we simply cannot rebuild our stock index anymore. So we are really lucky to have, in this case, to have the automatic indexation of the enterprise stuff, because that's indexing that can index on the fly for just the latest change set. And that's really great for us in this case.